Hi, welcome again to another studio workshop live here from HOFA-College. Today we are going to talk about routing and signal flow in your DAW. Sounds kind of technical, maybe even boring, but I think it's not, and it's a really important topic because whatever you do with a routing and how the signal flows in your DAW and in your mix, in your production, affects so many things, the way your mix is going to sound, the dynamics affecting each other in a complex routing. And today we're going to talk a little bit about the basics of the routing setup in your DAW, of the signal flow in your DAW, and also talk about some a little bit more sophisticated techniques. And yeah, I want to start with the basics. I want to show the things in Cubase, but of course you can try to follow it with your own DAW, whatever it is. Most DAWs have a similar setup, not exactly the same, of course, but similar things. One or two more electro-oriented DAWs have a kind of a different approach. One DAW that is a little bit more different is FL Studio. If you're working with that, maybe you have to transfer it to your software, and maybe I will also tell you some things that don't work in FL Studio. We will see about that. And I know some things about FL Studios that are really different than in other DAWs. However, a lot of things are just the same. And so I want to start with the basics. And yeah, I prepared a project for that. Just let us take a look to that. And that's mainly some audio files and a MIDI file in the DAW, the drum loop that is playing like this. So, okay. And all those DAWs are oriented to an old studio setup with a tape machine and a mixing board. The tape machine is a playback machine, and the mixing board is kind of, yeah, mixing all that stuff together and setting the routing for that. And here in our tape machine, and that is the project window, the audio files are playing back, or if not audio, it can also be something like a MIDI instrument, which is just not only recorded but also a live input setup. And the important thing to understand is where is the signal coming from and where is it going to, where is it routed to or into. And that is yeah, a really important thing to understand. And let's start at the beginning of the signal flow, and that is the playback of the audio file, the drum loop, and the first point where things are affected in Cubase is a so-called Preggain Control. That is this control here, and I can make things louder or quieter. So you see, this is the first volume control, and it's not to be mixed up with a fader. The fader has another position in the signal flow. The pre-gain, or in some DAWs it's only a gain knob, is very important for the volume leveling at the beginning of the processing chain. So the first thing we have to understand, and that's very obvious in Cubase, it's not in other DAWs, but it's the difference between stereo and mono files. And this is, the drum loop is a stereo file. You can see two channels, left and right. And you can also see here in the meter that they are a little bit different, that left and right is not exactly the same, and that's why it's a stereo file. A mono file is only one channel, and it's played back in only in the center of the stereo speaker system. And that is important to understand, because when we talk about stereo, it is not exactly one track or one channel we are talking about, but it's two channels. It's the left and the right channel. And you can see this in the metering of your channel. And I want to start with explaining a little bit about the metering. Don't worry, we're not gonna spend much time with that, but it's important for your understanding. So when I pan the stereo channel to the right side, the metering shows left or right. In this case it was right, and now it's to the left. Okay, but we can also change the way the metering is showed. We can switch to here we are, post panner or input. I'm sorry, I forgot to switch to English, but I hope I can explain it to you anyway. So to input, post fader or post panner. So if I go to input, you can see nothing is changing when I put the fader down, and nothing is changing when I put when I turn the panning to one side. So if the way I switch the metering, the way I perceive my processing is changing. So we have always to understand what we see in the metering, because the decisions we make for the loudness, for the volume, for panning, they can be affected by the way the meter shows us things. So the usual way to show the meter is either post fader or post panner. So I think for me, it's in the mix, it's normal to use post panner. So when I change this, the meter shows what I'm doing, and so you can really understand and adjust what you do with the plugins, with the compressor, with the panner, with the EQ or whatever. So it's really important to know this. For example, in Pro Tools, you only have pre-fader metering, and the metering is always before the panner. So in Pro Tools you cannot see what the panner does, but on the other hand, a stereo channel is also originally, it was in Pro Tools, is only is originally two mono channels and not a real stereo channel. So that is kind of different. Okay, just about the metering. So the next thing in the signal flow is insert. I think everybody of you have heard the word insert before. It's something is a slot in the mixer channel where you insert or put in plugins or effects or EQs, compressor, whatever. Whatever you do there changes the sound, and it's after the pre-gain, and it's also about after one other thing where you can change the volume, and that is the so-called clip gain. And that is something that almost any DAW has, a way to change the level or the loudness of an audio clip. And in Cubase it's done with the mouse wheel. You can see here the level is going down, or you can see here the loudness, the Lautstärke, and it's it was originally set to 0 dB, and when I change that clip gain, it's going down here in the metering as well. So that's really important to understand, because whatever you do in the inserts can be affected by the clip gain. Let me show you this with a very easy example. This is a compressor. I guess you know the basics of compression a bit. When a threshold is passed and the loudness of or the volume of the signal is reduced according to ratio and the attack and release time, that's not so important, but it turns down the volume. And I have prepared a rather heavy compression in this example. Okay, you can hear something is happening. So if I turn down the clip gain, there's much less compression. So that means the clip gain is in front or before the insert in the signal flow. And that is so important to understand because it can be the other way around. If I turn up the volume, the compressor is working a lot more. So if I want to change the volume, I have to understand at which point I do this. When I do it with a clip gain or with a pre-gain in Cubase, it affects the compression that is set in an inserted plug-in in an insert slot. And if I want to change the volume after the compression, I have to use something else. I have to either use the output gain. Oh, sorry. Or I can use the fader, of course. Okay, so that's yeah, the usual way of a inserted effect in the signal flow, but it also can be different. In Cubase at least, and in some other DAWs as well, you can move an insert from pre-fader or before the fader or in front of the fader to post-fader. And what's happening then is that the volume fader also affects the level of processing. And that is rarely used for an insert. In most situations we use an insert pre-fader, but sometimes it can be really interesting to use a compressor or whatever, or another dynamic tool, and use it after after the fader, right? And it's always like that. The channel is showing the direction of the signal flow from top to bottom, and the fader is usually the last element before it's going to the next output or whatever. But we talk about that in a few minutes. So we have the volume setting with the clip gain and the pre-gain. We have the insert effect. We can also use other effects than a compressor in that, of course. And we have the fader. But I think most of you have heard about sends. What is that? A send, an effect send, or a bus, or what else can it be called? Auxiliary send. That is also something that is said about that sometimes. Is an additional output to another input. The usual way we let our signals flow is the output of the audio track of the audio channel is going into the stereo out of the mixer, which is usually also the output to our which is what we hear, where the speakers are connected to, and which is also rendered into a stereo file when we export an audio mix down for a mix of our song, of our project. But we can also do an additional routing into an additional input, into an auxiliary input, and that's why it's also called auxes. And a normal way to do this is to use sends. In Logic, for example, it's buses. In Pro Tools, it's they have, I think, the usual sends. And in FL Studio, you have to connect the channels with this funny little connection. But in principle, it's just the same. It's an additional input, additional to the stereo out. So the acoustic guitar in that case is routed to the stereo output. You can see this here in the routing stereo out. And you can see it also here. So when I turn the volume down here, it's also quieter in the stereo out. So we have the dry signal of the acoustic guitar, and when I want to add some effect on it, usually something like a reverb or a delay or a chorus, I use a send effect or an effect send into an effect. That is the reverb here. Okay, that is the reverb. I'm using this one here, it's the IQ reverb, and you can see here is the input. And the signal of the reverb can be heard here in this return channel. It's like an extra channel in the mixer. And to show you what only the reverb sounds like, I can go to this one here. That's a listen button, and then I only hear the effect. And that is what the pure reverb channel sounds like. And yeah, the level of the reverb is determined by the level that I adjust here with the send control. It's usually something like a fader or a knob or whatever. In Cubase, it's a fader, and it's has a volume. It has a value of in dBs, decibels, and when it's set to -10 dB, it means that the full level is at 0 dB, and level that is by 10 dB quieter than the full level is sent into the reverb. So if I put this value down, it's less reverb. If I put it up, it's more reverb. If I set it to 0, it's sent into the reverb with its full level. So at this point we hear the original signal and the reverb with the same amount. The reverb has the same technical level as a dry signal, but that's too much reverb in most cases, so I put it down to a sensible level. Okay, one important thing to understand about send effects is whether they are pre or post fader. The usual way is post fader. That means when the signal is getting quieter, there's also less signal that is sent into the reverb. But sometimes it can be interesting to use it as a pre-fader. And then I do it here, and it's changing the color in Cubase. So I do just the same thing again, and I make the reverb put it a little bit, I adjust the send level into the reverb and make it a little bit louder. So, okay, when I put down the volume of the direct signal now, by turning down the fader, the reverb level is not changing. So even if there's no direct signal anymore, the reverb is just as loud as it was before. And that is something that you have to understand, because it can be a nice effect if you want it to have it like that. But if you didn't know that you set the sends to pre-fader and you change the volume of a guitar, for example, and you turn the level of the guitar down, and in the end you will have a lot more reverb on that guitar than before. Then it's not only getting quieter, but it's also getting much wetter, much more reverb on that signal. So that is something that is really important, that is very relevant for most of your mixes, whether you use pre or post fader sends, but also if your DAW supports that, pre or post fader inserts. But as a rule of thumbs, use insert in most cases as pre-fader inserts, and use reverbs and send effects in most cases as post-fader effects. It's not it's not a general rule. There are a lot of reasons to put a reverb as a pre-fader effect, but normally a post-fader send is a more sensible solution. So, okay, let me just check my my notes. Yeah, I'm almost been through that project. Just one more thing, I want to show you the channel in this DAW, because it illustrates the signal flow, yeah, pretty nicely. So we can take this one, it's better for showing up. Come on. So we have the inserts, we've seen that before. And oh, this is the piano. I want to use this one here. Okay, sorry. Come on. Yeah, here we go. So we have the insert, that is the first processing point after the pre-gain and after the clip gain from the audio file. We have the inserts. We have either pre-fader or we have post-fader. And in most cases, like I said, it's pre-fader. And the order of the inserts is also the order in the signal flow. If I add another plug-in, for example, an EQ, it's also really important to understand that the order of the plugins or the effects in the inserts is really important. Let me show you this with a very easy example. I just put a low cut. Okay, so all the low end is cut and it sounds really thin and awful, but it's happening after the compressor. So okay, maybe I use a little bit less compression. Still enough. Okay. And maybe I put down the clip gain again. So yeah, sounds better like that. Okay. So I have reduced the low end and the compression is still working. So if I turn this on or off, the compression is not changing. gain reduction of 12 dB, gain reduction of 12 dB. So if I change the order of the plugins and put the compressor after the EQ, it's much less compression because there's much less energy in the low end and the signal is much quieter. And so this is really important to understand that it makes a huge, or can make a huge difference whether you put the compression in front or after the EQ. So it's not about what sounds better or worse, it's about what is changing when you change something. And you have to always keep in mind that the signal flow affects not only this this one signal, but it can also have an effect on maybe something that is happening in the stereo out or in a group channel. And that brings me to the next thing. I want to start talking about groups, and I will do this in a minute. But before, let me just check the channel again. So we have the inserts and we have the routing, and we have the output routing, and here you can say where it's going into a group or into the usual stereo or master bus, whatever you want to call it. And yeah, that's the output routing, and we have the sends. We didn't put a send in this channel, but I can do this. Just use with the reverb here. So turn it on, and then we have reverb on this one as well. And then the last step, or the last chain, what is it called? Kettenglied. The last element in the signal flow is the fader, and it of course affects the most relevant factor, the volume of a channel. And included or next to the fader, but in front of the fader, is the panner. And yeah, that's a signal flow. Output from the tape machine into the pre-gain or into the inserts. If there is no pre-gain, then a channel EQ, if there is one in your DAW, then the sends, and then the fader, and of course the output routing. The usual way your DAW comes up with is it's routed into the stereo out. Here it's in Cubase, it's a part of the channel strip. It's also part of the channel here that you can see in your mixer window. In other DAWs it's pretty similar. You have some spot in your mixer where you can set the output, and yeah, that is about that. And now I want to start talking about groups, because if I route everything into the master out directly, I have to set every level of every instrument, of every track for itself. And if I want to say something like, I want to make the band a little bit louder in relation to the vocals, that is really time consuming if you want to do it fader by fader. And so what you can do is to route more than one track, 2 or more tracks, into a group. And I just simulate this here with this mixer and say add a group channel to the selected channels. And then I can say stereo. Yeah, of course I need a stereo group, because it's not a mono track I'm using here, it's several stereo tracks. Okay, so I have a group now, and I have one fader, and I can change the volume of 2 channels in the mixer without changing the mixer or the fader level of one of these channels. Sometimes it's a little bit mixed up with the VCA faders or DCA faders to be more accurate in a digital setup, which is set for voltage control amplification or amplifier or digital controlled amplifier. And that is something different. Just for a short example, I change the level of the group, but these faders stay the same, so I can change that fader, and it's only the piano that is getting louder. But if I use VCA faders, and just to stop this, I do this, and then we move on to the next project. I can, come on, where is it? VCA fader, here we go. So I have linked these two channels, and when I now move one fader, the VCA fader, the fader of the original tracks are moved, and it's something different from a group. It's also different for another reason, but that's going too far right now. So I think that is this for this one project, and I will move on to the next one and show you a little bit about grouping in a final mix. Come on. So I have to load another project. It's loading. Okay, here we go. So this is just a little band project, and with some channels. Most of it are instruments, virtual instruments. Some of them are played via MIDI, some are programmed, and there's also some vocal tracks, but we'll concentrate on the instrumental right now, just for the understanding the concept of group routing. And yeah, I just play a few bars. Okay, what you can hear are some drums, a bass, a guitar, and this beginning of the song only a Rhodes as an instrument, a keyboard instrument, and that's about it. So the drums is not only one channel, but it's separate channels. You can see here it's a snare, a bass drum, overheads and cymbals, ambience tracks, toms, hi-hat and ride, and every single one of us is playing right now, except the toms that are only playing one or few fills. So these drum tracks are all routed into a drum groups. That is this one here. And the advantage is I can use the fader to set the level of the entire drum set with just one fader. Okay, it's automated, so I can turn it off. Okay, and that's a really nice thing to do. And another advantage is I can also use some inserts in the channel of the drum set, of the group channel. It's a complete audio channel, and I can use compression, EQs, and I can use also, if I want to, another send effect in the group effect, for example. What I always do, but I know people are doing it in separate ways, in different ways also, that I route the reverb of the drum set into the drum group, just because I think that reverb is a part of the drum mix, a part of the drum sound, and when I want to turn up the drums or turn it down, I want to include the reverb in that volume adjustment. So the reverb, the return of the effect return of the reverb is also routed into the group of the drums. And you can see this. Let me do this a little bit larger here in the big window. You can see the where is it? Drums here at the side here. The output routing of the reverb is routed into the drums, and the drum group as another one is routed into a next group that is a playback group that is called PB in my case, playback, and this is this one here. And you can see there are many inserts, there are many plugins in the various group channels, and all the group channels in Cubase are labeled with different colors. They are blue. They have blue faders, and effect channels have purple faders, and the normal instruments and audio tracks have lighter white or yellow faders. Okay, and that's the way routing is working. You can route various audio channels into a group, but you can also route various group into a next group, a superior group. And I'm using here a drum group, an instrument group, and drums and instrument are together routed into the playback group. But you can also route effects into a group, and yeah, all of that combined is a very powerful way to get control over your mixes. But it's also a very powerful way to destroy your mixes. If you don't understand your routing and you lose the oversight of that complex project, you have to listen very carefully what's happening. For example, if you route everything into a playback group, let's say, and you have a limiter or a compressor in that group, and you turn up things, make them louder, and you wonder why nothing is happening. That is happening because there's a limiter or a compressor that is crunching everything together. And if you're not really experienced with compression, you may not hear that something is really crushed and destroyed. And I can hear that a lot in the mixes that our students send to us for analysis. And so be careful with your routing, and be careful with compression in your routing, in your group routing. And the main and the most important thing is understand your routing, and either better start a little bit with an easier setup rather than to make it too complicated or too complex. So this much about routing. Let me close this project and move on to the next one. Okay, yeah, that is rather important. I have prepared it. What do I want? Sidechain. Yeah. Okay. Another important thing that probably most of you have heard before, sidechaining. What is sidechaining and why is it done? Yeah, let me show you something. This is a standard setup for sidechain processing. It's a bass drum and a bass, kick and bass. Yeah, pretty boring, and it's really basic. It's just the same kick drum repeated for many bars, and a bass sound which I really made over easy. Just one note for 2 bars and then it's changing. And that not only sounds boring, but it also makes for a really boomy and uncontrolled low end. And one thing that most techno and electronic music producers wanted in the beginning when they first came up with sidechain compression is to keep the kick drum in front and steady and the most powerful and most important instrument in the track, but the bass on the other hand should be audible as well, and it should be powerful as well, also as powerful as a kick drum, but without interfering with the kick drum. And so what they came up with is to use a compressor on the kick drum, on the bass, sorry, that is not triggered by the bass itself, but it's triggered by the kick drum. And so every time the bass drum is playing, the bass sound is compressed because the input says, hey, the kick drum is playing, so I make the bass a little bit louder. And that is implemented with a sidechain compression. And I prepared that, of course, and I show you the result. So, exactly. So. Okay, I show you without the bass drum, just the bass. And that is a typical sidechain compression of a bass drum. I also make some EQing and some saturation to make the sound a little bit more interesting. Just it sounds like that with just to add a little bit of character to the sound. And then the next thing is this one, the compressor. And you can see it's pumping and it's reducing heavily, but it's not reacting to the bass, but to the bass drum. How is this done? There's a kick drum, and in the kick drum is a send effect. And this is this one. I turn this one off. It's not necessary now. So we have a bass compressor send, and this is this one. And we have the compressor inserted as a plug-in in the bass channel. And you remember probably the signal chain and the signal flow in the inserts from top to bottom. The EQ is the first one, and then the saturator is the next one, and then there's the compressor. But the compressor is not reacting to the audio of the bass, but to the audio of the bass drum. And that is determined in the sidechain routing. And as an input of the sidechain, I set the kick drum, and that's what we see before. Here we have a level of -5 dB, and I go up to 0 dB, and then you can see here it's 0 dB now as well. So these are connected, and the sidechain input now is responsible for the compression of the bass. You know, it's starting the pumping effect that everybody wants who's working with this, and the setting of release time and look ahead and threshold and ratio, all that is setting and determining how much compression and how long the reduction and the going back to the original level takes. And that is the effect we want to do with sidechain compression. These sidechain routings are very similar in different DAWs. Like I said before, in FL Studio, for example, it's a little bit different. You have to find out the way it is connected, but if you draw the line and if you make a connection between two channels in FL Studio, it's usually, and it's already, a sidechain routing into the next channel. So that's a little bit different and different DAWs. Okay, yeah, that's it about the sidechain compression. And I want to move on to the next implementation of a sidechain setup. Oh, no, I've already opened it. I just have to activate it. Here it is. Because this is a really nice way to use sidechaining. Most people connect sidechaining with electronic music, with pumping bass drums and pumping bass sounds, or even pumping instrumentals, but it can be also used for different purposes. And that is a rather interesting setup. It's called ducking, and I want to show you the setup first. This is a playback and a speaker that is speaking on top of the playback, and that is a voiceover, it's usually called. Can happen, for example, in podcasts or in the radio or in documentaries for TV, whatever. If you keep both volumes uncontrolled, it's not a good solution. Either the music is too quiet or too loud, either the voice is not loud enough or too loud or whatever. Just let me show you this.
In general, the audiobook is understood to be a reading of a text by a narrator.
Okay, I assume you understood nothing, because the playback is almost as loud as the voice, and the voice sounds really muffled and so first thing I do is I adjust the frequencies, and now the voice starts sounding like this. Sorry.
In general, the audiobook is understood to be a reading of a text by a narrator,
instead of like it was before.
In general, the audiobook is understood to be a reading.
That, of course, makes the voice more intelligible over the music.
In general, the audiobook is understood to be a reading of a text by a narrator.
But still, when it's getting a bit quieter, you don't understand nothing. So, next step, compression.
In general, the audiobook is understood to be a reading of a text by a narrator.
Okay, so it's getting better. So we used our insert slots to add EQing and compression, and I also used a de-esser for this one, because in the end, the S's, the sibilants are getting too loud.
In general, the audiobook is understood to be a reading of a text by a narrator.
Okay, so this is just for reducing the sibilants, the loud S's and sh and t sounds, just to make a more balanced sound of the voice. But the most important thing I want to show you is the ducking of the music, of the playback. And for this, we use sidechaining again. And this is a Docker plugin. It's brand new, by the way. It's a system Docker, and it's part of the system all bundle, of course. And it has a sidechain function. It needs that sidechain function, and as input of the sidechain, the voiceover is set up. So if I activate this, you can see nothing's happening so far.
In general, the audiobook is understood to be a reading of a text by a narrator. Although the various characters in a literary reading may well be performed in different ways.
So what we have, that when there's no voice, the music is playing with the originally set volume. We can hear the music, we can hear the details in the music. And when the speaker is entering, the compression starts to react.
In general, the audiobook is understood to be a reading of a text by a narrator.
And you can adjust these settings with the attack time in milliseconds, the hold time, how long is it at least as reduced, and how long is it taken to be to going back to full level. And what we really liked, or what I really like about this, is that it has a look ahead time, a really long look ahead time. You can even set it to to something like a full second, and then it's starting too early, of course, for this song. Come on.
In general, the audiobook is understood to be a
it was too early.
Understood to be a reading of a text.
So I put it back the way it was before. Yeah, 77 milliseconds. Then it starts slowly before the voice enters, and with a slow attack time of 125 milliseconds.
In general, the audiobook is understood to be a reading of a text by a narrator.
And it's a very soft and musical way to fade the volume of the playback when the voice enters. And that is a really useful implementation of a sidechaining setup. And you can even use a Docker for sidechaining or for compressing a sidechained kick, for example, or kick and bass compression. And that's really, a nice tool. And sidechaining can be really, really helpful in many situations. So I want to move on to another really interesting routing setup. And now we're going to be a little bit more complicated, more sophisticated, and more complex techniques are coming up. This is, let me open the project and then I tell you. So, okay, it's the same music we had in the project before. Let me turn down the volume a little bit, it's not so important. And usually, as I explained before at the very beginning, we have when we have a stereo channel, we have a left channel and a right channel, and this is stereo, and I can pan it to the left or to the right, and that's it. That's a usual stereo setup. To demonstrate this, I have used our system plugin and insert at a dual mono routing. I can use this, for example, to set different volume levels for the left and the right channel. Turn down the left channel, of course, it's only the right channel that's left over, and I can even mute them. So there's nothing left. That's stereo, left and right channel. But another way to split a stereo signal is not into left and right channel, but into mid signal and side signal. And yeah, just let me show you. So I also inserted a mid-side routing system, and it sounds just the same like the one in the stereo setup. Oh. No, this way, sorry. Okay, you can hear no difference. Nothing's happening if both plugins are set to 0 dB. It's just the same. But the mid-side plugin is affecting different signals than the left and right routing. So what I just turn out the side signal, you can see that it's the side signal of the stereo signal, and this is left is the mid part of the sound, and you can see this also in the goniometer. That's a very important tool to control and to adjust your stereo settings and your stereo width in a mix. And when I turn off the mid signal and turn on the side signal again, it sounds pretty weird. Now you can hear when you're listening to it with the headphones or with your speakers on that there's only signal that is so wide and it sounds really phasey. But in addition, in combination, in combination, it just sounds fine. What can I do with this knowledge? Okay, I can, for example, say I want to reduce the mid level a little bit. I want to make it wider. Or I can make the mid part louder. Whatever I want. But leveling mid and side signal is just a very basic implementation of that mid-side routing things. And I want to show you a more interesting setup of a mid-side routing. Just let me put up the next project. Here it is. Yeah. And now we're combining 2 or 3 things we have talked about before. We're using a group, a playback group. We're using the output routing. We're using sends into a sidechain, and we're using mid and side processing, or mid processing basically. So we have a playback. And don't wonder, it sounds a little bit off because I just put it together from some loops and I made some time stretching and pitch shifting. And so it sounds a little bit processed and not very natural, but it's okay for just for show. I like the groove. Okay, that's the playback. Very basic, just as an example. And I have that vocal track.
I'm the one that needed closure. I'm the one who needed change.
As I said, you can hear the processing of time stretching and pitch shifting and whatever. But don't worry, it's not important right now. So, when I play it together.
I'm the one that needed closure. I'm the one who needed change. Couldn't leave this all unanswered.
And the vocals are pretty dynamic. Not extremely dynamic because it's already processed and there's some reverb on it and already some compression. But nonetheless, at the end of especially the first 2 phrases,
I'm the one that needed closure.
it kind gets of lost in the playback, and so it I could maybe just turn down the playback a little bit at this spots like this.
I'm the one that needed closure.
Yeah, that's a bit too much, and it's not really elegant, but kind of rough. But I can do that much more, conveniently. And for this, I'm using a compressor. And you've seen it before. That's the sign for sidechain compression. And as the input for the sidechain, I used the vocal. And you can see in the vocal there is the sidechain sent into the playback compressor. So, and it's bypassed still, but this compressor is not only a normal compressor. No, it's set to the MS mode. And as we had before in the examples, M and S is for mid and side. And here in this case, the side processing is turned off, and it's not compressing anything on the side of the MS sound. So, yeah, just let me show it. I want to play it back and show you. No, here we go.
I'm the one that needed closure. I'm the one who needed change. Couldn't leave this all unanswered.
Okay, and what you can hear and see in the compressor is that each time the vocal is singing, the mid part of the signal is reduced.
I'm the one that needed closure.
Now you can hear slowly getting back with a rather slow release time or long release time.
I'm the one that needed closure.
And then it's back to full level, but only the mid signal. And the side is not affected. And if you listen to the side signals, for example, the percussion, the right cymbal and the drum loop, you can hear that it's only that information in the mid of the signal is affected. Just let me play back the compressed playback, but without the vocals. You can especially hear it on snare and the bass. Now the snare is louder and the bass is getting back. Again, just concentrate on snare and bass. And this way, sorry, that was the wrong one. And this way the voice can stand clear and audible in front of the band without being louder than before. And another way would be to, okay, I make the vocals louder, but that cannot always be the solution. Sometimes it's a nice way to support an automation, for example, just to add a little bit of mid compression. Just put down the mid signal a bit whenever the vocalist is singing, and this way the singer has more place.
I'm the one that needed closure. I'm the one who needed.
Yeah, and another way to do this, and with even less audible processing, is to use the mid signal, but not to process it as a whole, but to process just different parts or different frequency ranges of the signal. And so the vocal is taking place in the mid range mainly, but I use two frequency ranges for this one, the low mid and the center mid-range. And the low mid in this case is around 300, 330 hertz, and the mid-range is around 1 kilohertz. And if I do this, compressor is off, yeah. It's even more effective for making place for the vocals, but it only affects in the mid-range. So the bass, for example, is not affected in the low frequencies, but only in these ranges where it can clash with the vocals. So.
I'm the one that needed closure. I'm the one who needed change.
You can see the reduction.
Couldn't leave this all unanswered. Couldn't deal with all this pain. I'm the one that needed closure.
Yeah, and that's some really nice setup for mid-side processing, mid-side routing, and it's using, of course, mid-side processing, but it's using a sidechain routing as well. There's a send going into the sidechain of the playback group from the vocal channel, and we have hopefully explained all those things that are happening in a mixer setup. Not all possible things, but the basics things, from the input over inserts and sends to the output routing. We've worked with groups. We used the sends into a sidechain of another plugin, and we used not only mono and stereo channels, but we also used mid-side compression. So I think we got a pretty good overview of possible routings in a mixer and in a mixing project without going too much into detail. But of course, you can do much more complex and complicated routing setups. But I think, and I hope you believe me when I say routing and the understanding of your routing and the signal flow is so essential. And it's really, the more complex your mixes get, the more important it is that you understand what is happening in those mixes. And you can really get much better results when you understand your routing and your setup in your own mixer projects. Yeah, and that's about it for today from me for this topic. If you want to learn more about routing, about signal flow, about compression effects, send effects, and so on, take a look at our website at HOFA-College.com. And maybe we'll see each other soon here at HOFA-College. That's it from me for today. Have fun, have a nice evening, and enjoy your productions. Bye-bye.